the calligraphic M is that the domain containing all state spaces, all states?
Yeah, so usually, very often in kind of applications you have it just the state space, usually just bunch of real numbers, and it's Cartesian very often. But whenever you have nonlinear problems, the state space tends to be a manifold because there are, quadratic and other terms in your equations. So then one uses curly M to indicate a manifold rather than just a real number to dimension D. That's the curly M.
You wrote G belongs to the curly M, and then there is phi1, phi2 up to phi n. And G is a group, isn't it?
G is the group element.
So M
and phi1 to phi n are the angles, their parameters. When we were studying discrete groups, then we put a discrete index on a group element because we had 6 group elements, for example, from 0 to 5 or 1 to 6.
Mm-hmm.
Now for continuous group, we have to replace that by a continuous parameter because we can turn by any angle specified by, let's say, a real number in this particular parametrization. So that's what phi's are, they're parameters of rotation.
Now, you said G belongs to the calligraphic M, and M is the manifold, and it's the state space, right?
G doesn't belong to that particular M. M is a state space, so that's what G acts on. So M is a collection of vectors, any possible vector that lives in the state space, and G is morally a matrix that acts on it. So, most of our application, this will still be just a matrix. It's a bit complicated. I talked about group orbit. So this was, if you took a swimmer in the ocean and you turned the swimmer around, then what it will mean in the state space, there will be a continuous curve in the state space of different orientations of the swimmer.
Right.
The group orbits are actually tracing lines, or if you have more parameters, surfaces or volumes in the state space. So, action of your group is embedded in your state space because everybody who belongs to the same group orbit, whose dimension is this n, number of continuous parameter, is morally the same swimmer, the same object.
Okay.
So that's why I said the group manifold, meaning the action of the group on a state in a state space is embedded in this curly space M because it's a subspace of it.
Okay. Yeah, I understand now. Thank you.